if you want to find out the value of sine 36, now if you see 35, if you multiply by 5, you'll get 180. Okay. So we start by saying let A is equal to 36 degree. Multiply both sides by 5. So you get 5A is equal to 180 degree. Just like when we are finding out our 18 degree angle, sine 18 degree, cos 18 degree, and tan 18 degree, we break 5A as 2A plus 3A. Okay, now when we are finding out sine 18 and cos 18, if we were to find out sine of 18 degree, we were taking sine on both sides. So we'll take sine here also on both sides. But before that, we'll just write this as 2A is equal to 180 degree minus 3A. Okay, and now we'll take sine. So now you have sine 2A is equal to sine 180 degree. 180 degree you can write as 2 into 90 degree, even multiple of 90 degree. Now even multiple of 90 degree means what? Even multiple of 90 degree means sine will remain sine. And what is the quadrant? Which quadrant is this angle in? It is in the second quadrant. So
Second.
sine remains positive. So this becomes sine 3A.
3.
So 2A now you can write from multiple angle formula as 2 sine A cos A. From double angle formula. Triple angle formula for sine 3A is 3 sine A minus 4 sine cube A. Now you take everything on one side. Now you can take sine A common. That means now either sine A is equal to 0 or you can have 2 cos A minus 3 plus 4 sine square A is equal to 0. But sine A we have taken as A as 36, right? So sine A is sine 36, which we all know is not equal to 0. Therefore, the other one has to be 0. That means 2 cos A minus 3 plus 4 sine square A must be equal to 0. Now, if you see here, in 2 cos A minus 3 plus 4 sine square A, you have a cos and a sine, and you have a sine square in fact. So you can change your sine square to cos so that everything will become in terms of cos. We change sine square A to cos square A, just as we were doing earlier to get a quadratic in cos A. So you'll get here 2 cos A plus 1 minus 4 cos square A. So now you can rewrite this in as a quadratic in the quadratic form. 4 cos square A minus 2 cos A minus 1 is equal to 0. So that means you get 4 cos square A minus 2 cos A minus 1 is equal to 0. Now you can solve this quadratic by Sridhar Acharya. That means cos A is equal to minus B plus or minus root over of b square minus 4 into a into c divided by 2 into a. Okay, so you get here 2 plus or minus square root of 4 plus 16 divided by 8, which is 2 plus or minus root 20 divided by 8. Now 20 is the pure surd, you can write it as a mixed surd as 2 root 5. Now you can take 2 common to get 1 plus or minus root 5 by 8. And this 2 will cancel here. So you get 1 plus or minus root 5 by 8. So taking positive signs, since cos A is equal to cos 36 is greater than 0 because it's in the first quadrant, taking positive sign, we get cos 36 degree is equal to root 5 plus 1 by 4. But we did not need the value of cos 36. We wanted to find out sine 36. So, but since we know cos 36, we can find out sine 36. Hence, sine 36 is equal to square root of 1 minus cos square 36. Put the value of cos 36, and now you can expand within the radical. Expand by a plus b whole square formula. Now you can take the LCM within the radical. So you're getting here square root of 10 minus 2 root 5 divided by 4. This is the value of sine 36. Okay. So we got the value of cos 36 and then we found out the value of sine 36. Okay. Now, if you see the next question here, the next question here is find the value of tan 36. Tan 36 is very easy once you know the value of sine 36 and cos 36. Tan 36 degree, sine 36 degree divided by cos 36 degree. Put the values. Sine 36 we have found above to be square root of 10 minus 2 root 5 divided by 4. And cos 36 we have found this out to be root 5 plus 1 by 4. So 4 and 4 cancel here. So you get square root of 10 minus 2 root 5 divided by root 5 plus 1. Okay, that's the answer. And no point rationalizing the denominator because you have a radical in the numerator also. Besides, we use the value of sine 36, cos 36, and tan 36 in these forms only. You don't need to remember them, but sine 18, cos 18, and tan 18 definitely you will have to remember. Okay. In fact, if you remember the value of sine 18, cos 18, and tan 18, you can get the value of sine 36, cos 36, and tan 36 also by your multiple angle formula. That's another way of finding the value of Sine 36, cos 36, and tan 36. Okay. So that finishes with the fourth part. We now come to the fifth part. Let me just erase this. We come to part 5. You have to find out the value of sine 292.5. Now sine 292.5 degree, you change it into an acute angle first. So what can you write this as? You can write this as 270 degree plus 22.5 degree, which can also be written as sine 3 into 90 degree plus 22.5 degree, which can also be written as, now because it's an odd multiple, the sign will change to cos. Now we have to see which quadrant this is in. You see that this is in the third quadrant, right? So this will be minus. Yes.
Sir, it is in the fourth. Third plus 22
Oh,
and a
yes,
half.
fourth quadrant. Okay. This is in the fourth quadrant. Fourth quadrant. So this should be negative. Even then it is negative because sign is negative in the fourth quadrant.
Yes, sir.
It's a minus cos 22.5 degree. Okay, so and cos 22.5, I think we have already found out earlier. So this is equal to minus, if you cos 22 and yes, sine 22.5 degree. We have found out here. Okay, let's find out cos 22.5. Sine 22.5 we had found out. Let's see how to find out cos 22.5. So we have, because the double of 22.5 is 45, 2 cos square 22.5 degree is equal to 1 plus cos twice 22.5. This is how we found out the value of sine 22.5 also, if you remember. 1 plus cos 45 degree, which is equal to 1 plus 1 by root 2, which is equal to root 2 plus 1 by root 2. So that means cos square 22.5 degree is equal to root 2 plus 1 by 2 root 2. Okay, so rationalize this denominator here, multiply the numerator and denominator by root 2. Which is equal to 2 plus root 2 divided by 4. Okay. So that means cos 22.5 degree is equal to square root of 2 plus root 2 divided by 2. We ignoring the negative sign because you know cos 22.5 is positive. Okay. So we have got the value of cos 22.5. So we can now write hence sine 292.5 is equal to minus cos 22.5 degree is equal to minus root over of 2 plus root 2 divided by 2. And that's your answer. Clear?
Yes, sir.
We can move on to the next one now. And as I told you yesterday also that whatever problem I'm going to give for the Friday's exam will be from question numbers 1, 2, and 3. From here. So once 3 I finish, after 3 you won't be getting any questions on Friday. After question number 3. So let's start with question number 3. Evaluate 2 tan 22.5 degree divided by 1 minus tan square 22.5 degree. Okay. Now, if you compare with the formula of tan 2 theta, you realize tan 2 theta is equal to 2 tan theta divided by 1 minus tan square theta, right? So now if you see, this is of this form, right? Where theta is equal to 22.5. So therefore, what is this equal to? You can directly write this equal to tan twice 22.5 degree, which is equal to tan 45 degree, which is equal to 1. Okay.
Yes, sir.
So this was a 2-line problem. That's over. Now the next problem, I think there's a small slip of pen here. This should be a cube here. Okay. Instead of 2, this should be 3. Just make this change. So number 3, question is evaluate this 8 cos cube pi by 9 minus 6 cos pi by 9. So from here, what I do is, because you know that cos 3 theta, let's recall this, okay, is equal to 4 cos cube theta minus 3 cos theta. This is the triple angle formula for cos, right? So now from these two, if I can take 2 out, what am I left with? 4 cos cube pi by 9 minus 3 cos pi by 9. So now if you compare this with this, you see this is of this form. That means this can be written as cos thrice of theta. And what is theta here? Theta here is pi by 9. So this can be written as twice cos 3 times pi by 9, which is twice cos pi by 3. Okay, and pi by 3 is same as cos 60. Cos 60 is half, is 1. Clear?
Yes, sir.
Can move on to the next one now. Number 4. ABC, now till here only you will get your question, okay? So when you're preparing for your test, only prepare till this. ABC is an acute angle triangle inscribed in a circle of radius 5 centimeter and center O. The sine of angle A is equal to 3 by 5. Calculate without using tables all this. The length of BC, sine of OBC, sine of BOC, sine of uh, cos of BOC, all these. Okay, so let's draw this. This is your circle and you have an acute angle triangle in this. Acute angle triangle means all the angles of the triangle are acute. This is an acute angle triangle inside this. And you have the center of the circle here. Okay. Call this ABC. And let's call the center of this triangle as, let's call this O. Now, if you last year, I don't think I did circumcenters with you, right? Now, what is the circumcenter of a triangle? Circumcenter O is actually the circumcenter of this triangle. Okay. Because O is the center of the circle and the triangle is inscribed in this circle. Therefore, O is called the circumcenter of this triangle. Okay. And so here the sine of angle sine A is given to you as 3 by 5. Okay. So okay. So O is the center of this. O is called the circumcenter of this triangle. Okay, so what you do is you join okay, radius is 5 centimeter, so that means all this is 5 centimeter. Okay, so now what you have to find out here is length of BC. Okay, now something that you must observe here is that in order to find out the length of BC, if I drop a perpendicular from here and call this point M, okay, then BC will be twice of BM from the chord properties, if you remember from your class 9 knowledge, that if any straight line perpendicular to a chord bisects the chord, isn't it? So therefore, OM is a perpendicular on the chord BC, so it must bisect the chord. So whatever is the length of BC, it is twice the length of BM, right? So if we can find out the length of BM, then we can find out the length of the chord BC. So how to find out the length of chord BM? Let's suppose this angle to be theta. Let us call this angle to be theta. Therefore, sine theta is given to you as 3 by 5. Okay, for convenience sake, we are taking this angle to be theta. Okay, so therefore, what should be BOC? What should be this angle? From your class 10 angle properties of circles, angle subtended by an arc at the center is twice the angle subtended by it on the remaining part of the circle. Therefore, what is angle BOC? BOC is twice angle
So,
BAC,
theta.
right? I say let angle BAC is equal to theta. This is equal to 2 theta then. Okay. So now if this is equal to 2 theta, that means this angle here must be equal to theta and this angle here must be equal to theta, right?
Yes, sir.
So therefore, I can say angle BOM is equal to angle MOC is equal to theta. Okay. Now, now look at this triangle, triangle BOM. You can see triangle BOM. This is the point O. Let me write it once again. Okay, this is the point O. And you can see triangle BOM. In triangle BOM, OB is the hypotenuse. You know the hypotenuse. And what is BM? BM is the base, right? So you can find out in triangle BOM, sine theta is equal to BM by OB. What is the value of sine theta that we have here? 3 by 5 is equal to BM by OB is given to be 5 centimeter. That means BM we can find this out to be 3 centimeter. Hence, this answers your question number 1. Length of BC is twice of BM is equal to 2 into 3. 6 centimeters is the length of BC. That answers the first question. Next question is sine of angle OBC. Which one is angle OBC? OBC is this angle. Okay. You need to find out the sine of this angle. In order to find out the sine of this angle, you need the length of OM, right? Sine of OBC is equal to how much? OM by OB. Do we know the length of OM? No, we don't know the length of OM, but we know the length of OB. Let's find out the length of OM. You can use Pythagoras theorem to find out the length of OM. So OM is equal to root over of OB square, hypotenuse square, minus BM square, which is your base square. Root over of 5 square, and BM is 3 centimeter we found above. So this is equal to 25 minus 9, which is root 16. equal to 4 centimeter. So therefore, sine OBC is equal to OM is 4 centimeter we found here, and OB is the radius 5 centimeter. That is sine angle OBC is equal to 4 by 5. Third one, sine angle BOC. Let's locate the angle BOC first. Which one is angle BOC? BOC is the angle 2 theta is equal to sine 2 theta. Can you see this 2 theta angle here? Sine BOC. This one.
Yes, sir.
BOC is 2 theta. So sine 2 theta. And what is the formula for sine 2 theta? 2 sine theta cos theta. Now, do you know the value of sine theta? Yes, we know the value of sine theta, I think. Yes, here. Sine theta, we know 3 by 5. And if we know sine theta, can we find out cos theta? Yes. So we write this as sine theta root 1 minus sine square theta. Because all the angles are acute, you don't need to worry about the negative sign. Okay. Now put the value twice 3 by 5 into root 1 minus 3 by 5 square. You can find this out to be 2 3 by 5 into 4 by 5, which is equal to 24 by 25. Okay. And finally, the fourth one. Fourth one here is cos of angle BOC. BOC is again 2 theta angle, right? So cos angle BOC is nothing but cos 2 theta. And how do you find out cos 2 theta? We know sine theta, right? So we can write cos 2 theta as 1 minus 2 sine square theta from multiple angle formula. 1 minus twice sine theta is 3 by 5 square, which is equal to 1 minus 18 by 25, which is 7 by 25. That's it. That solve all your 4 questions. Okay. What is the next question? Let's see if it is a short one. Yes, it is a short one. So we can solve this also. Number 5. Number 5. Given. Question here is sine theta is equal to A, sine 2 theta is equal to B. Find an expression for cos theta in terms of A and B. Hence, find a relation between A and B not involving theta. That means you have to eliminate theta. So, given here, sine theta is equal to A. And sine 2 theta is also given to be B. Find an expression for cos theta in terms of A and B. So, if sine theta and sine 2 theta is given, so we have sine 2 theta is equal to B, right? Now, what is the formula for sine 2 theta? Multiple angle formula, 2 sine theta cos theta is equal to B. Now, do we know the value of sine theta? Yes, we know the value of sine theta. Put it 2A cos theta is equal to B. That means what is the value of cos theta we are getting? B by 2A. And that was the question. Find the expression for cos theta in terms of A and B. So we have got cos theta in terms of A and B. Next question is find the relation between A and B not involving theta. Now, as you see that you know the value of sine theta and you know the value of cos theta. So we have, you know the identity sine cos square theta plus sine square theta is equal to 1. Put the value. Cos theta we have got above as B by 2A. Sine theta is simply A square. And therefore, your required expression which does not involve theta here is this. Okay, which is the required expression. Not involving theta. Okay. Okay, perhaps I can finish the 6th one also. 6th one is also a short one. Number 6, given tan A is equal to 1 by 5. You need to find out the values of tan 2A, tan 4A, and tan 45 degree minus 4A. So let's start with the first one. Tan 2A is equal to, from the formula, multiple angle formula, tan 2A is 2 tan A by 1 minus tan square. Put the value. Tan A to be 1 by 5. Okay. So that is tan 2A. And you can simplify this. I'm not simplifying. You can simplify this to find out the value of tan 2 as 5 by 12. Next, we also need to find out tan 4A. Tan 4A, if you see, can also be written as a double angle formula as tan 2 into 2A. Tan 2 theta. That means this is equal to 2 tan 2A divided by 1 minus tan square 2A. Right? So now above, we know the value of tan 2A above. Put it. Okay. And you can also simplify this to get 120 by 119. And finally, you have tan 45 degree minus 4A. Now this is a compound angle formula that we have to use, tan A minus B. Tan A minus B is equal to tan A minus tan B divided by 1 plus tan A tan B. Put the value of tan 45. 1 minus tan 4A divided by 1 plus tan 4A. And now you can, tan 4A, you put the value here. So 1 minus 120 by 119 divided by 1 plus 120 by 190. Take the LCM in the numerator and denominator and simplify. You will get this as minus 1 by 239. Okay. So I'll stop here then.